Right, so we'll continue looking at complex numbers. Okay, so this section will finish up with multiplication and division. And then we'll get back to section 5.3. We'll start it today, but we won't finish it till tomorrow. The part we have to finish tomorrow is probably about 15 minutes. It's very, very short, which is good because we only have half a class tomorrow. All right, so we talked about this number I. Okay, and remember, it is a number. Okay, it stands for this outer last. It just gives you a pattern to remember. Or it's the distributive property twice. Distribute A to both, and distribute BI to both. So any questions on that idea? Okay, so I'm not going to write out what you get here with all these letters because it's going to look very confusing if I do it out like this. It'll look much simpler if I just do it out with numbers. All right, so let's try to multiply 2 plus I times 1 minus I. Okay, so Skylar, if I follow that FOIL pattern, what would be the first two things I multiply together?
2 times 1.
Yeah, so 2 times 1, that'll give me 2.
2 times I.
Yep. I. And then 2 times negative I. And Connor, what's 2 times negative I?
Minus 2I.
Yep. And Jake, what would I do next?
Multiply I and 1.
I and 1. And what's I times 1? Yeah, just I. You can write 1I or just I, that's fine. And the last thing I'm going to do is positive I times negative I. And now we'll look at this in a couple steps. Jared, what's a positive times a negative?
That's definitely a negative.
That's a negative. And now what's I times I?
I to the second.
I to the second. Okay, and we need to come back to that, but that's where we start. Okay, any questions on just that first step? Okay, Marquise, do you see any like terms I can put together there?
2I and I.
So the I and, what did you say the other one was?
Negative 2I.
Yeah, the negative 2I. What do you get if you combine negative 2I with positive I?
I.
Well, think of it this way. Negative 1 plus 2. Sorry, negative 2 plus 1.
Negative I.
Negative I. Okay, now, if that was listed as an answer on the test, if it was multiple choice, and you pick what I have written right here, I would mark that wrong. Okay, because it's not done yet. What do I have to do? Do what?
I don't know.
Sure.
I know I've done it before.
It's what we just talked about. Yeah?
To simplify the I squared.
Right, you got to simplify I squared. What did we say I squared is? Negative 1. Okay, be careful with your negatives. Okay, that's a subtraction sign, so I just brought that down. And then I changed I squared to negative 1, so I got another minus sign. So what happens with those two minuses?
Plus.
Becomes plus. Okay, so 2 minus I plus 1. And now I'm at my last step. Okay, I have some more like terms I can combine. What's 2 plus 1? 3. And that's your answer. Okay, whenever you write it, make sure you always do it in standard form. Number and then letter. And that's it. That's all there really is to multiplying. So, any questions on that one? All right, so we'll try one more with multiplying because in order to divide, yeah, you have to multiply. So multiplying is pretty important. So take a second and try that one on your own. 8 plus I times 3 plus I. Okay, so when we multiply this out, start with 8 times 3. Here's your 24. You have 8I plus 3I. So what I'm going to do is just combine those together in that step. And then, what's I times I?
I squared.
I squared. Okay, if you wanted to change that to -1 at the same step, you could. If not, okay, we need to just change it now. So instead of having a +1 to the 24, it's a -1. Okay? Questions on that one? All right. So in order to do division, okay, we have to learn what's called a conjugate. Okay. So first, I'm just showing you the symbol for a conjugate. Let's say you had a complex number a plus bi, and I'll just call it complex number z. So the complex number z is equal to something, in this case, a plus bi. If you put a bar over it, that means they want the conjugate. Okay, so we know what the symbol is for a conjugate, but I still haven't even explained what is a conjugate. So the conjugate of z, which is a plus bi, is a minus bi. Okay, that's all you have to do to find the conjugate. Okay, so to find the conjugate, you just change the sign of the imaginary part. That's what negate means. Change the sign of it. Don't do anything to the real part. Just change the sign of the imaginary part. So next what we'll do is I'll give you a list of numbers and I'll just ask you, here's the original, tell me the conjugate. And then I'll show you how the conjugate is used when we do division. All right, so I have a column. On the left is the number. On the right, that symbol means the conjugate. Okay, what would be the conjugate of 3 plus 4i? Jerry?
3 minus 4i.
Yep, 3 minus 4i. Okay, how about the conjugate of -8 minus 2i? Yep, just say
-8 plus 2i?
yeah, -8 plus 2i. All right, how about the conjugate of 5i? Shakira? -5i. And lastly, how about the conjugate of 3? Think carefully about that one. Selenia? 3. It stays the same. Okay. If you're like, well, why does that stay the same? Think of 3 like this. It's 3 plus 0i. Okay, there's no imaginary part. The conjugate is 3 minus 0i. Plus 0 minus 0, same thing. Okay, so any questions on what a conjugate is? All right, so now I want to find what happens when you multiply 2 conjugates together. Right, I want to take 3 minus 4i and multiply by its conjugate, 3 plus 4i. Okay, something different is going to happen here. Okay, some things are going to simplify pretty nice. And just by looking at that, I can already tell you the answer is 25. Okay, and I didn't do it in my head. Okay, I just used a shortcut because I know that a lot is going to cancel out. So let's do it the way we've done it and see if you can figure out what just disappears. Okay, start with what's 3 times 3? 9. Then you have 3 times 4i, which is how much?
12i.
And then 3 times -4i?
-12i.
-12i. So that's always going to happen. So if you're multiplying conjugates, you don't need to do the outer and the inner. Those two are always just going to cancel out. But I do need to do this one. -4 times +4. Just start with that. That's a -16. And what about I times I? I in the second. So this is all gone. And I'm left with 9 minus 16 times I squared. But what's I squared? -1. And what happens if you subtract a negative? Which is what we're
Adding positive.
adding positive. And 9 plus 16, there's my 25. Okay, so to multiply conjugates together in your head, all you really have to do is take this number, square it, take that number, square it, and add them up. 3 squared is 9, 4 squared is 16, and then add. You could say, well, does it matter if you use the negative or not? No, because if you square negative 4, it's still 16. Okay, so what would that be without foiling it out? Just using that pattern. Okay.
25 negative minus 16
Plus.
plus
Plus.
16.
Yep, 25 plus 16, which is 41. Okay, so you could FOIL all that out, but we're going to have problems that have conjugates in them, and it's going to save us a lot of time if you just can learn that pattern. 5 squared plus 4 squared. Okay? If you don't want to learn the pattern, just FOIL it out every time and cancel what cancels. Okay, so that's the formula that we've been using. Okay, so here's your, well, actually, these are your complex numbers. You want to multiply them together. Take A and square it, take B and square it, and add them up. So what do you notice about the kind of answer that you got? 41, 25. What kind of numbers are those? They're real. Okay? They are real numbers. So when you multiply conjugates, what happens is all the imaginaries cancel out. That's why we do it. Okay? And that's what you have to do in division. All right. So again, this is just a shortcut. If you really don't want to learn it, don't just do it the long way. But this is a lot faster. All right. So in order to divide two complex numbers, the first step is to find the conjugate. And the second step is to multiply the top and the bottom by the conjugate. Okay, so to divide two complex numbers, multiply the top and the bottom by the conjugate of what's in the bottom. Okay, and the reason we have to do it that way is because whenever you divide complex numbers, you're not allowed to leave I in the bottom. So we need a way to make all the I's disappear. And how can we do that? Multiply by the conjugate. And that's going to make all the I's disappear from the bottom. Okay, so we'll do example 6 after, but I want to start with example 5, which is a little easier. There's a little bit less distributive property in this one. Okay, so what is my conjugate in example 5? Okay.
Minus 4i.
Yeah. It's 3 minus 4i. So we'll put 3 minus 4i in the bottom and the top. Now this part we should be able to do pretty quick. Let's use our pattern. What's 3 squared? 4 squared? And then add those two together. That's the whole bottom. Now the top, there's no shortcut for the top. Okay, this time it's not too bad to do it. You're just distributing a 1. So it's just 3 minus 4i. Okay, any questions up to that step? Okay, that's not standard form. Standard form means you have to have a real part and then a separate imaginary part. Okay, so I'm going to show you how you break this up. Okay, your real part is 3 over 25 minus, because we had a minus, and your imaginary part is 4 over 25. That is how the answer would be written on the test. Right, so you basically just take each number and put them over 25 separate rather than together. And that's it. You don't have to do out 3 over 25. Don't find the decimal unless they ask for it.
You can't put the I next to the 4.
You can, whether you put the I in front or you put it right. Okay, so what is my conjugate in example 5? Jerry?
3 minus 4i.
Yeah. It's 3 minus 4i. So we'll put 3 minus 4i in the bottom and the top. Now this part we should be able to do pretty quick. Let's use our pattern. What's 3 squared? 4 squared? And then add those two together. That's the whole bottom. Now the top, there's no shortcut for the top. Okay, this time it's not too bad to do it. You're just distributing a 1. So it's just 3 minus 4i. Okay, any questions up to that step? Okay, that's not standard form. Standard form means you have to have a real part and then a separate imaginary part. Okay, so I'm going to show you how you break this up. Okay, your real part is 3 over 25 minus, because we had a minus, and your imaginary part is 4 over 25. That is how the answer would be written on the test. Right, so you basically just take each number and put them over 25 separate rather than together. And that's it. You don't have to do out 3 over 25. Don't find the decimal unless they ask for it.
You can't put the I next to the 4.
You can, whether you put the I in front or you put it right there, that's the same answer. It's kind of like, let me go back. It's kind of like when you do y equals mx plus b. If you have a fraction, what they usually do is they just put the x kind of right in the middle in front of it like that. It's not wrong if you did something like this, putting the letter in the top. It's just they usually don't.
Okay.
But these are the same thing. Okay. Any questions on example 5? All right. So take a sec and try example 6. Okay, and this will be the end of our review of complex numbers. Okay, so then after this, we'll get back to section 5.3. We'll do a few things in that, and then we should be done. We should be done pretty early today, so you'll have some time to start the homework. Okay, so this one a little different than the last one because this time you got a complex number in both the top and the bottom, but it doesn't change the process. What am I going to multiply top and bottom by?
The conjugate and the denominator.
Right, the conjugate, and you have to make sure you pick the one Jasenia said of the bottom. Okay, not the conjugate of the top. And Jasenia, what's the conjugate of the bottom?
5 plus 12i.
5 plus 12i. 5 plus 12i. Now the denominator using our trick should be really quick. What's 5 squared?
5.
And 12 squared?
44.
Add them up,
169.
and that's it. Okay, unfortunately for the top, you got to do it out. Okay, so 1 times 5 gives me 1 times 12i.
12i.
And what's 5 times 4i?
20.
So we've got a 12i plus a 20i. So 32i. And what about 4i times 12i?
48.
It's going to be 48i squared, which is really what?
Negative 48.
That's a negative 48. Okay, you can write that step if you want, but if you don't write it, I'm fine with that. If you do that part in your head, just don't make a mistake. What's 5 minus 48?
Negative 43.
Yep, negative 43 plus 32i over 169. And now I'm just about done. What's my last thing I got to do? Separate it. So the real part is negative 43 over 169. And the imaginary part is 32 over 169. Hey, so any questions on that? So again, I know I already said it twice, but just don't mix this up with addition. Okay? Only FOIL if you don't see a sign between the two parentheses. If you see a plus sign in there, that's a lot easier. You don't have to do what we just did. Okay, that goes back to yesterday. All right, so the last section we're going to look at, and we're going to split this over 2 days, is 5.3. And it has to do with two things. One, graphing a complex number, which is very, very easy. And then the second thing is how we write complex numbers in polar. Okay? All the complex numbers that we've had so far, this is rectangular. Okay? And I'll show you why when we graph it. All right. So in the complex plane, you don't have an x and a y-axis. Okay? You have a real axis, which replaces the x, and an imaginary axis, which replaces the y. So if you want to graph a point like 2 plus 3i, okay, what's the real part in 2 plus 3i? 2. So you go to 2 on the real axis, and what's the imaginary part? 3. And that's it. So that's how you graph the point 2 plus 3i. And now hopefully you can see why this is a rectangular coordinate, because you're going left and right, up and down. This has nothing to do with an angle. If it had an angle in it, that would be polar. Okay? There's no angle. It's just a left and a right and an up and a down. That makes it rectangular. All right. How about 4 minus 8i? How would I graph that one? Go which way?
Right 4.
Right 4. All right.
Down 8.
Down 8. Yep. So that's 4 minus 8i. How about negative 8? Left how many?
8.
Yeah, left 8. What's the imaginary part?
0.
0. It's like negative 8 plus 0i. Okay, you don't go up and down. And lastly, how about 5i?
It'd be on the axis.
Just go up.
Just go up 5, yeah. Okay. One of the mistakes I usually see with this stuff, people switch the axes. Real is horizontal, imaginary is vertical. Just remember that, okay? I've seen people graph 5i by going 5 to the right. No, 5i is 5 up. Okay, so you'll have 2 questions on the test just like that. Okay, just have you graph them. Okay, so any questions on graphing a complex number in the complex plane? That's probably one of the easier things on the test. All right, and the last thing we'll look at, which we'll start today and finish tomorrow, is complex numbers written in polar. Now, I know normally when I write a complex number, I've been using like a plus bi. Right? That's how I've been doing it. Since we're getting into graphing now, a lot of times when you graph, you use the letters x and y. So if you want to continue using a and b, that's fine. But it's going to make more sense if I do x and y. Now, the other thing, when I write a complex number, does anyone notice anything funny about this part? The i's in the beginning. You can put the I at the end. Okay? What I'm doing is I'm trying to make it match what's in your book. Okay, so there's going to be a formula that we get, and the book writes the formula with the I in the beginning. It doesn't really matter, but that's how they do it. Okay? That's rectangular form. Okay? X is movement left and right on the real axis. Y is movement up and down on the vertical axis. And I think if I use those letters, it'll help you to remember which one's which. X is your real, that's left and right. Y, that's your vertical. That's your imaginary, up and down. So now, if we want to change that to polar, you've got to get rid of the X and you've got to get rid of the Y. What are the two things that you have to have in polar?
Radius and
Yeah, you're going to need a radius and you're going to need an angle. So we have a formula for converting X to polar and Y to polar. We did that on probably Monday, a couple days ago. Does anybody remember the formula to convert X to polar? It was X equals, and then there's an R and a theta and a trig function in there.
R cosine theta.
Yeah, R cosine theta. And how about Y? R sine theta. Okay, these are formulas we've already proved where they came from on Monday, so we're just going to use them today. And what I'm going to do is take X, and I'm going to change X to what I just drew the arrow. And I'm going to take Y, and I'm going to substitute that in right there. Okay, and by doing that, it's going to show me what a complex number would look like in polar. It's going to be R cosine theta plus I times sine theta. Oh, and don't forget your R. Okay, so R cosine theta plus I R sine theta. Now, what do both of those have in common in front of the trig function?
R.
They have an R. Okay, and anytime you have something in common, instead of writing it twice, what you can do is just put it in front and write it once. Okay. If I take R away from the cosine, what am I left with? Yeah, just left with the cosine. What if I take R away from the second thing?
So I
I sine theta. That is how you write a complex number in polar. Okay, it's R cosine theta plus I sine theta. Okay, and it's all based on the two formulas we learned on Monday. Okay, so there's two things you have to figure out, just like we did on Tuesday. Okay, now this part we did yesterday. How do you find R when you're doing things in polar? You use the Pythagorean theorem. R squared equals x squared plus y squared. And what trig function do you use to find theta?
inverse tangent.
Inverse tangent. And just like we did before, if you're in quadrants 1 and 4, it's inverse tangent y over x. What if you're in 2 or 3? Yeah, you have to add the 180, or pi if you're doing it in radians. Right? So I'm not going to write that all down again. You already have all that from yesterday. Okay? And it's exactly the same. All right, so we'll finish up with writing this point in polar. So it's square root 3 minus I. Now, what is the imaginary part? They didn't write it this time. Careful, -1. If you want to put it in, you can. All right, and now we're going to take that and convert to polar. All right, so let's start with my radius. R squared equals x squared plus y squared. Okay, so remember, the first number is your x, the number next to I is your y. Okay, so what's my x in this case?
3.
Square root of 3. So I'm plugging that in for x. And what am I going to plug in for y? The number next to I is a -1. Now, if you plugged in positive 1, it wouldn't matter because when you square it, the negative goes away. But try to plug in correctly. Okay. When you're finding your radius, don't ever plug the I in. It's just that number and that number. Okay, not the I. Okay, so what's the square root of 3 squared? 3. And what's negative 1 times negative 1? 1. So r squared is 4. So what's my radius? 2. Yep. Now just hang on to that for a second. We'll come back to it when we write our final answer. What else do I have to find besides the radius? I got to get the angle. Okay. Now when I find the angle, what do I need to know about this point first? Okay. That's why I just taught you how to graph. Okay. So if you were to graph this point, it doesn't really matter what the number is. It's positive and then a negative. What quadrant does that land you in? 4. Right down. Somewhere around there. Okay. When I'm in quadrant 4, is that the one where I add the 180 or I don't need it? I don't need it. So inverse tangent of what's y in this case? Yep, it's always the number next to I. And what's x? Square root of 3. Okay, so let's type that in and see what we get. Inverse tangent of negative 1 divided by square root 3. Let's do it in degrees. Okay, the reason I'm going to do it in degrees is I already said this yesterday. I don't think anybody's going to recognize that. Okay, but if I do it like this, you're going to get a nice answer. It's negative 30. Which now, if I wanted it as a radian, it's pi over 6. Okay, any question on the angle? All right, so now we have to write our final answer. So remember the form. It's r, where did I have it? R cosine theta plus I sine theta. Okay, so I'm going to write r parenthesis cosine theta plus I sine theta. Now, when we have a negative angle, there's a couple ways we can get rid of the negative. What's something you can add to negative 30 to make it positive, but it doesn't affect the answer? You can always add 360 to any angle, and it won't change the answer. It'll just make the angle bigger. So that is one of 2 ways to get rid of the negative here, if they asked you to do that. If they didn't, you could stop right where we are. But I'm just showing you how to get rid of the negative in case I ask it on the test. So you could write cosine, what did you say it would be, Connor? 330 plus I sine 330. Okay, that's one way. Okay, these are exactly the same thing. If you type in the cosine of negative 30 on your calculator, in fact, I'll just do it. Cosine negative 30, cosine 330. Same thing. Didn't change the answer. Okay, any questions on writing it the first way? Okay, second way.
Don't you do it in radians?
Yes, everything I'm doing here you could also do in radians, but I'm not going to do that for this problem. So the second way to get rid of the negative. Okay, I want you to look at the difference between cosine 30 and cosine negative 30. What's the difference? There isn't. So technically, the negative with the cosine doesn't matter. So you could just get rid of it. The negative with the cosine never makes a difference. Now, let's see if that's true with sine. Okay. Sine of negative 30, sine of positive 30. Is there a difference there?
Yeah.
Not a huge difference though. What's the only difference? Right, one's positive and one's negative. So you can't get rid of this negative, but what you can do is move it in front, just like it is here. This has a negative in front of the number. Okay, so that's what you can do with the sign part. Take the negative, move it in front. Okay, so with cosine, if it's a negative, you can just get rid of it. Doesn't make a difference. With sine, don't get rid of it, but you can move it to the front. Okay? And the second way, sometimes that's a little bit nicer to get rid of a negative because it keeps the angle the same size. It doesn't make it up around 300 something. Okay? But all three of these are correct. They're all different ways of writing it. This way, I think, is a little new. We never learned that before. But you should have known this one. Okay. So any questions on that? Okay. And now tomorrow, we'll see why would you write a complex number in polar. If you do, it takes everything I just taught you in the first half of the class and makes it go away. You don't need any of it. Okay? We can do things a lot easier than all that foiling you got to do when you multiply complex numbers. No, you don't really have to do any of that. Okay? If you understand polar. If you don't understand polar, then yeah, you do. But it's going to be a lot easier to do this tomorrow now that we know polar. All right, so the first part, that's on the complex numbers, okay, multiplying and dividing on page 560. And the second part, page 333, that's on writing complex numbers in polar.